is problem number 11 from January 31st. Again, it's a system of two equations, and we want to solve this by substitution. So we want to isolate one of the variables, and again we want to look at the two terms on the left side of this equation, the two terms on the left side of this equation. We've got a negative 2x, 3y, another 3y, and an x. The x is the simplest, so we'll want to get this variable, this x, by itself. So I'm going to write this equation over here. Now to get the x by itself, I'm going to do the opposite of what they've done. They've added 3y, so I want to subtract 3y from both sides of this equation. These two terms will simplify. We're left with x, and we're just going to write these two terms down. Remember, we don't combine these because they're not like terms, but we can write either term first. I'll put the negative 3y first, and then the negative 5. So now, whenever we see an x, we're going to replace it or substitute negative 3y minus 5. So we have to go to the other equation, not the equation that we just got this expression from, but we want to go into this equation. So here's the x right here. I'm going to rewrite this equation, but when I see x, I'm going to write this instead. So let me write that equation again here. I'm going to write negative 2. I'm going to say x, but I'm going to leave it blank for the moment. Negative 2x plus 3y equals 1. So remember, when I see an x, this is what I want to write instead. So in this parentheses, this quantity is going to be negative 3y minus 5. Now we can simplify this. The nice thing about this equation is there's only one variable. Even though it shows up twice, we don't have an x and a y, we just have a y. So let's simplify it by distributing negative 2. Negative times a negative is going to give us positive 6y. Negative 2 times negative 5 is positive 10. We still have positive 3y, or plus 3y, and 1. Now we can combine some like terms. Here's a 6y and a 3y. If we combine those, 6y and 3y will give us 9y. We still have the plus 10, and we still have the equals 1. To get the y, we're going to want to do the opposite of add 10. We're going to want to subtract 10 from both sides. And if we do that, these two terms will simplify, and we're left with 9y. And it's going to be equal to 1 minus 10, which is negative 9. Now to get the y by itself, since they have multiplied by positive 9, we're going to divide by 9. Those two 9s will simplify. And now we get the y by itself. Negative divided by a positive is a negative 1. So that's part of our answer. Y is negative 1. We're not done yet because we also have to find x. We're going to go back to our two original equations. Either one of these will be just fine to substitute. I'm going to write the second one. I like it better. It looks a little easier. So I'm going to write x plus 3y. And the way I'm going to write 3y is with the y in parentheses for now. Equals negative 5. Now we had already said that since y is the same as negative 1, whenever we see the y, we can replace it with negative 1. That's what I'm going to do here. Instead of writing x plus 3 times y, I'm going to write x plus 3 times negative 1 equals negative 5. Now this is going to give me, when I multiply these, when I simplify this, 3 times negative 1 is negative 3, minus 3. We still have negative 5 here. To get the x, since they subtracted 3, we want to add 3 to both sides. And if we simplify these, we'll get the x by itself like we wanted. And if we add a negative 5 and a positive 3, we're going to get negative 2. That's the other part of our solution. Our solution has two parts, and we have to write those two parts as an ordered pair. Because the order matters, the x has to come first. The x is -2, we write that first, put a comma. The y is -1, we want to put that second. So our solution is the ordered pair, -2, -1.